Why I have considered first transformer, then induction motor, then synchronous machines, because all these three machines are AC machines, alternating current machines. Once we are finishing this, then we can aram se go for the direct current machines, and they are having some they are interlinked with each other. If you say see the EMF equation, almost all and other factors are linking, so you can relate to it very easily. So apart from that, in this class, we'll be solving one problem on induction machine, which has time and again appeared. What I'm trying is to optimize. We are having limited time on online, so I'm trying to solve as many problems from the past V2 examinations. I have some papers I collected, 10 years papers I have, and I'm seeing some repeated problems and certain problems which can appear in the examination to make the paper look very tough. So those problems also we are doing. I'm recording it. I'm putting in the Google Classroom. If you are having very low network, I'm also uploading on YouTube. There also you can see. If you have any doubt, you can ask us. You can write in the Google Classroom also. So let's start today's class. So the choice of specific loading. So basically, what is this specific loading? Is your magnetic average magnetic flux density. So the product of specific magnetic and electrical loading. Your magnetic loading is your BAV, is your specific magnetic loading, that is your flux by area, and this is ampere conductors, that is ampere per turns, determines the output per unit volume for a given speed. Means how do you determine the speed of a machine? That is determined by definitely by the dia of the machine and the peripheral velocity, that is pi dn. So when I am showing this symbol upwards, this means increase. When this arrow is downwards, it would mean decrease. So it says to increase the power output for a given volume, the constants BAV and AC have to be increased. So choice of now firstly we will go for the specific magnetic loading. So the choice of the specific magnetic loading, how does what parameters does it govern? Now the number one parameter that is governed by it is the iron loss. So iron, when I'm talking about the iron loss, iron means core. In the core is made up of cold rolled grain oriented steel, and this particular loss in the core is also known as iron loss, whereas the loss in the winding is known as copper loss. So core loss, iron loss, one and the same thing. So a higher value of BAV, if BAV is higher, means flux by area is BAV. So that would mean area is less. Okay, means higher flux density in the teeth and the core. Okay, this increase the core loss component. This increase the core loss, decreasing the efficiency and increasing temperature rise. So suppose if the core loss increases, what will happen? If the loss increases, you have your efficiency. Efficiency is your output by input. So your output is equal to input minus losses, or your input is equal to output plus losses. So if you write efficiency is equal to output by input, so input is what? Output plus losses. So loss increases means efficiency will decrease. Na? You're getting my point. Loss increases, efficiency will decrease. So the increase in the core loss decreases the efficiency, and increases the temperature rise. One more thing is there. Let me see. Can I write something? Text and image. Okay. It is changing the color, huh, Viramani? Okay. Are you there?
Yes, sir.
Yeah. So the increase in the yeah. So the increase in the core loss decrease the efficiency and increasing temperature rise. Now this was about your efficiency. Okay. Now let's see what about your voltage. Suppose your voltage, a machine with high terminal voltage, it will require more slot space. Means uh, slot the number of slot, the distance between the slots would increase. In such cases, a high value of BAV is not recommended. So another, the second thing is your short circuit current. So a machine with the losses BA will have a higher leakage reactance. So leakage reactance XL is equal to your 2 pi FL. So a machine always having the inductive component in terms of L. So a machine with this lower value of BA will have a higher leakage reactance. So if it has a lower value of BAB, your leakage reactance increases. That results in the lower current under short circuit condition. Hence, to control the short circuit this current, it is advisable not to choose higher BAB. Means higher BAB we should not choose. What higher BAB means, your flux is more, your area is less. So BAB is what current density, okay, flux by area. So higher BAB is only possible in numerator, flux is increasing and area is decreasing. That is the case for higher BAB. Now your flux is directly proportional to the current, because your flux is magnetic equivalent of your electrical current. So that means if your flux increases, your current also increases. If your current increases, means your short circuit phenomena is dependent upon your current. If you are shorting and higher value of current, it is resulting. So hence, to control the short circuit current, it is advisable not to choose higher BAB. Now another thing about the synchronous machine is, basically what synchronous machine alternator is. Already in the previous classes and semesters you have studied AC and DC machines. You had machines one wherein you had DC machines and transformers. Then you had machines two wherein you have studied induction machine and synchronous machine. So as far as the synchronous machine is concerned, it is the governing body which is controlling the power transmission distribution, because this machine actually produces the power which we are like consuming. Now this is the machine, this is called alternator. So in this synchronous machine, once you are utilizing synchronous machine in a power generating station, then there is transmission. It has having transmission, it's connected to the generator. Synchronous generator is connected to a transformer, that in turn is connected to a transmission tower, and that tower is again supplies energy or your power for a long distance. Then you have one pole mounted substation. So you have level of transmission, sub transmission. By the time it gets decreased and you have pole mounted substations, then service means, then these come to your home by distribution transformers. And then finally in your home you have your service main and you receive the power. But where the power is actually getting generated, with the help of these alternators only. So one important factor with this is the stability. So what is stability basically is that when this power is getting transferred, so synchronous power is directly responsible for the stability of the machine. So the machine should be stable in the sense means the power generated and the power consumed. For example, I am generating 100 kilowatt of power, and I am consuming 50 kilowatt, then it is okay. I have a spare capacity of 50 kilowatt. But what happens when I am generating 100 kilowatt and I am consuming 110 kilowatt? Is it possible? It is only possible in a bank, not in real life situation. What I mean, why it is possible only in a bank, because they only have the assets worth of 1 lakh rupees and they will give you a loan of 2 lakh rupees, but they don't have the assets to back it up. But in reality, does it happen with power systems? It will never happen, because if you don't have the backup capacity, you cannot generate, because in real time you have to supply. So what happens is that initially if your demand goes little high, means 1 or 2 kilowatts up, then that demand is supplied by the rotational energy stored within the machine. That generating turbines is there, and it supplies some energy and its frequency range becomes little less. So this synchronous power is directly responsible for the stability of the machine. It is also inversely proportional to the synchronous reactance. So you tell me, Thara, are you there? Sushmita?
Yes, sir.
Sushmita. Sushmita is there, no? One girl is. Oh, this is Thara. Huh?
Yes, sir. Yes, sir.
Okay. Yeah, 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 yeah. I need Sushmita online. Okay. what is what do you Shushmita HS? Okay. You tell me one thing. What is the formula like for your synchronizing power? Like E is equal to how much times? You see, one formula we have for power P is equal to root 3 Vs Is cos phi. That is okay for power. What about the power that is generated in the grid station? How it is represented? E is equal to or P is equal to P power generated in a grid station. You have any idea, Sushmita? Huh? In
I don't.
transmission and distribution? You tell. Yes, you have any idea or not? Yes or no? You tell. Hmm?
No, sir.
Sushmita?
No, sir.
Yeah, you tell. You don't have. Okay, no problem. Okay, okay, I will tell. Okay, stop. Okay, switch off your mic. So your this power is equal to synchronizing power, which is generated by the alternator, is given by the terminal voltage and the excitation voltage. That is your E into V divided by X into sine delta. And sine delta is the load torque angle between your E and V. Have you heard now, Viramani? This you have studied, right?
Yes, sir.
Your power would be equal to this power you have studied na November. E would be equal to this P would be equal to E into V divided by X and sine delta, where Xs is your synchronous reactance and E and V are your this terminal and excitation voltages, and the load toggle sine delta is between. So in synchronous machine you have studied this. If you have not studied, I will recommend you to study. I will upload one notes of synchronous machine, my earlier notes, to go through it. But it has got nothing to do with this particular thing. But overall, like tomorrow, if you go for some power company like Siemens or some, so it will help you. So a high value of BAV gives low value of excess. So improving stability. So for stability, what happens is that your power is represented by EV excess into sine delta. Now yeah, this is inversely proportional. Excess is inversely proportional. So excess, a high value of BAV will give you basically a lower value of reactance. So that improves your stability. Now another thing in synchronous machine is that your parallel operation. So there are some 3 4 conditions for parallel operation of an alternator. Anyone can explain me parallel operation of alternator? Anyone by choice? Like who's can anyone tell? Yeah, come on. Yes, yes, yes. Vanishri, you can tell.
So parallel operations.
Hmm? Parallel, yeah, parallel operation. In diploma,
Sir,
you have studied, na?
suppose
Tell in Kannada, no problem.
sir, in parallel
Okay,
operation,
suppose one generator.
two or more generation generator
Hmm.
operate in same to a time, and both generating frequency are same for transmission
Hmm.
purpose. And suppose one generator is shut down, remaining generator to continue to generate the force.
See, what you said is that, see, for parallel operation, the most important factor is the phase angle of the incoming generator, and the bus has to be same. First of all, the phase angle has to be same. That then only it will synchronize. And
Yes,
the second important factor is the voltage levels have to be maintained. Okay,
maintain the same.
so it
Phase sequence, sir.
same phase sequence. Phase sequence has to be same. Now one more important factor, what you told about frequency. If you read some local books, they will write frequency has to be same. But in standard thing, in practical thing, if you go there and if you read some good books also, the frequency of the incoming generator has to be slightly more than this you are connecting, because if it is less, means it will slow down the power system. So if it is more, okay, so that point I negate. Frequency is not to be same. The of the incoming generator, I will give you my notes also.
Sir, why
You
India
refer
and
one
other,
book electric.
sir? So why India and other
Tell
countries
me.
are
Yeah.
different frequency maintain, sir? India 50, other countries like 60 hertz.
See, this is a very good question. Time and again, it's been asked, and time and again on YouTube also. I very welcome this move. You have to ask like this question. See, what happened is India, the power system network was established by the British. Okay, and if you see the British system, you have 50 hertz system. So they have these currency notes like 1, 2, 5, 10. So you will see in India also, if you have the currency notes in the denomination of, you will get 10 rupees, okay, 20 rupees, 50 rupees, 100 rupees, 1000. You will not get 30 rupees,
200
200 also. That in the
and
multiplication of
2000.
that, you will not get 30, you will not get 40, you will not get 300, 400. You get, that's what I'm telling. 1 into 10 you will get. 2 into 100, 200 you will get, but you will not get 30. 2 into 1000, 2000 you will get. 50. 5 into 10, 50. 5 into 100, 500 also you can get. So the thing is that when they established, the Britishers established this system, the number system, and they installed the power plants, and they made it around the sea. The frequency, how does it come? Frequency comes by establishing the number of poles, and this ns is equal to 120 f by p. So they have set it basically from the number system, they have set the frequency range to 50. And wherein in the US system they have set the frequency range to 60 hertz. So it depends upon which country you are operating. Now if you go to British, they have the same 50 hertz system, and those countries which Britishers have colonized for most of the time, they have the same 50 hertz system. So you have to go back into the history for this. There is one more important question like this. Sir, in power system, many people will ask me, sir, why 11 kV, 33 kV, 66 kV? And certain people will reply because of the form factor 4.44, 1.11. Again, that is wrong. You don't have 11 kV, 33 kV, 66 kV. You also have 13 kV, 765 kV. Like that also you are having. So why this is taken 11, 33? Earlier, the power plant which was generated was in 10 kV or 10 kilowatts, which was DC. In DC, there used to be a lot of loss. So they used to keep that spare of one. So hence this denomination continued in the power system. Nothing to do with the form factor. You have to go back in the history. Hope I have answered your question, Fakresh. Are you okay?
Yes,
Hmm?
sir.
Okay. Okay, very good. Now let's go. Value of BAV is equal to, see here, this is the range of the BAV. It depends upon this. Now the temperature rise, a high value of this AC means what? Ampere turns, means increase in the amount of copper loss, increasing the temperature rise. So if your copper loss, basically what happens is that your loss, any form of loss, is the heating loss. And if you are using hot iron inside your this also called as press to press your clothes, so that also acts on the phenomena of heating loss. If you are using an electrical heater to warm, or your geyser, that is also converting electrical energy to heat energy, but that energy, heat energy, is a form of loss. So loss will only happen in a resistor, and it will result into heat. But again, I have told you in the class time and again, I am telling you again once more time, that your transmission line are predominantly inductive, otherwise they will also heat up. So one thing to be noted here. So sophisticated cooling methods must be employed to dissipate heat. So in your alternator or your transformer, you have that cooling tubes mechanism, and you have fan in every machine. In induction machine also you have that cooling mechanism, because it should not rise up a certain temperature level, because what happens is that then the insulation starts to burn, and if insulation continuously burns, and it will result into short circuit. It will result into short circuit. So voltage for machines with the high terminal voltage, more space is required for insulation. Now suppose you have a machine that has got this high terminal voltage, more space you require for insulation. Now if you have a machine with less terminal voltage, see, as your voltage increases, your insulation levels increases. So as your voltage is less, your insulation level be less. So For machines with height, more space for insulation, and so the space for copper is less. So hence, high value of AC cannot be assumed for this low voltage. Now again, synchronous reactance. A high value of ampere turns AC means ampere conductor. Okay, means higher synchronous reactance. Poor voltage regulation, lower short circuit current, and small synchronizing power. And now there are some stray losses in the friction and the windage and the mechanical losses. Again, a high value of your ampere leads to a higher stray losses. Now this was about your ampere conductor loss and your average flux density and the factors governing it. Now last class we have studied induction machines, so I was just going through many papers. I thought ki this question can come for 12 to 15 marks. Although we have done a question like this, but not exactly like this, because this question I found little bit tricky they have put, and 2 3 times I have seen such questions come, and people start feeling the paper is really difficult. And this is the way, if we can also solve this type of questions, so we'll be very confident when we are going to the examination hall. So we'll read out the question and we'll do it. So 15 kilowatt, 3 phase, 6 poles, 50 hertz cage motor has the following data. So this is the induction motor. Okay. So the diameter is given 0.32 meter, length is given 0.125 meter, number of stator slots is equal to 54. What I recommend you is that when you are sitting on the mobile, again you have all of you, when even in the classroom when you are sitting, you are doing one mistake. The mistake you are doing is that you are not making a separate notebook. Make a small notebook of 100 200 pages for one particular this thing. Okay, although at the end we will give you the notes, no problem, these notes are yours. But when you write in your own hand, it is very easy to understand your own notes, and if you have taken, you can relate to it. You can relate to it. And if you, but you don't have that habit, but you have to establish that habit. So if you are sitting and some of you are having pen and copy, write down and try with calculator, so that you will get a much insight. A 15 kilowatt 3 phase 6 pole 50 hertz cage motor has the following data. Your dia is 0.32 meter, your length is 0.125 meter, number of stator slots is equal to 54, number of conductors per slot is equal to 24. So total number of conductors would be equal to this per slot divided by this. So it would be 54 into 24. So that one thing we came to know. So current in each conductor is 17.5 ampere. Current in each conductor is 17.5 ampere. Your full load power factor, your full load power factor is equal to 0.85. This is lagging power factor. Okay. Another thing is that design a suitable cage rotor. Design a suitable cage rotor giving number of rotor slots, section of each rotor bar, and ring and so this is end ring and ring and effective resistance of the rotor. Given the full speed as 950 rpm. So this full speed means this is the rotational speed. Okay, 950 rpm. From here, can you calculate the slip? You can calculate the slip. How can you calculate the slip? Yesterday, some of you have done code training with me. Fakresh has done code training with me. I have told your slip is equal to your synchronous speed
ns
minus
minus
rotation.
1.
Yeah, ns
ns
minus
minus
nr.
n by ns.
Ns
N
minus nr by ns. So
plus NR.
yeah, so ns you can calculate 120 f by p. So this is a 6 pole. Again, I have told you, if you have to write a gate examination, or you have to go for ES examination or any state level JE AE examination, so you can get a government job, and government job means very good. You can or see, every job is good for that matter. I am not telling you that, it's upon your choice. So these questions are very important. So you can write, see, ns is equal to 120 f by p. So you can calculate your 120 into 50 divided by your number of poles. The 120 into 50 is 6000. 6000 divided by 6 is how much? 1000. So if you have 6 poles, means your ns would be 1000. You can remember, because in gate examination no need. If you have 4 poles, it is 1500. Similarly, if you are 8 poles, so you remember, for 4 poles usually A question will come either for 4 poles, 6 poles, or 8 poles. Okay, for you see, for 6 pole it is becoming 1000, for 4 pole it is becoming 1500. Now for 8 pole how much it would be? 8 pole
750.
usually 750. So like that 750, so you can remember. So now we have to do this question. So now the question is, please switch off. Your poles is 6, your stator current is 17.5, your dia is this, your length is this, stator slots is this. So he has not mentioned the rotor slots. Now no mention of rotor slots is there. When nothing is mentioned about rotor slots, we usually take them equal to stator slots. But if you are taking rotor slots equal to stator slots, then what will happen? A phenomena of cogging will happen. Your motor will only not start. So it should not be equal, not it should not be an integral multiple. So usually what we do is that to select a rotor slot, it should be equal to stator slot plus the number of poles divided by 2. So like this we will do. So the number of rotor slots is assumed a pair of poles greater than the number of stator slots. A pair of poles. So the number of rotor slots is SR is equal to SS, that is your 54, and this pair of poles. 6 poles is there, so one pair would be 3. So 54 plus 6 by 2 is 3. So this is 57. Okay, like that you have to assume in this particular thing. Current density is also not given, but earlier only in the induction motor I have told you we take it 7 millimeter square current density. So that also in the later question when we are going further I will be explaining. So for now you got the value 57. Now the number of stator turns per phase. See, uh, stator turns per phase for total 6 phases, Zs is equal to 6 times Ts. So Zs for this problem, Zs is equal to 6 times Ts. So total number of conductors is 6 Ts. 6 Ts is equal to number of stator slots 54 and conductor per slot. So number of conductors would be equal to this slot into this. So this cancels, this and this cancels. It will only happen when you multiply stator slots into conductor per slot. Stator slot is 54, conductor per slot is 24. So 54 into 24. Here stator slots and this slot will get cancelled. Only the total number of conductors you will get when you will multiply 54 with 24. So and this is equal to the total number of conductors, Zs. So Zs in a 3-phase system is equal to 6 times the total number of turns per phase. So your Ts would be equal to your Zs divided by 6. Same here, see here. Your Ts is equal to your Zs. Zs is 54 into 24 divided by 6. Now why I have written 2 into 3? This was for a single turn, and for 3-phase it is 3. So hence you will get this 216. Now assume this assumption we are being using already in the previous classes also we have used this assumption. Assume rotor MMF. Your rotor MMF happens to be 85% of your stator MMF. So again this SR into IB by 2, which we have seen in the previous class, we can directly write is equal to 0.85 stator MMF. MMF is what? Number of turns. This is ampere turns. Ampere is current, turns is your TS. So you get the value of your rotor bar current. So rotor bar current happens to be 0.85 into 6 IS TS into your rotor slot, rotor conductors. You have calculated this rotor, this thing, number of rotor slots. Rotor slots you have calculated, this is 57. So you can write your rotor slots is 57. Is given in the problem. Is is given in the problem 17.5. So you can substitute the value 17.5. Ts you calculated 216. So now you arrive at your this bar current. So one thing is asking is okay, tell me design a suitable case number of rotor slot, section of each rotor bar, and bring an effective resistance. So now you have to go for the effective resistance. How do we calculate the effective resistance? And to calculate the effective resistance, one assumption here you have to do is that let current density be 7 ampere per millimeter square. So area of each rotor bar, area of each rotor bar. Your current density rho b delta b is equal to IB into AB. IB rho b is equal to IB into AB. This rho b is equal to IB into AB, or other terms, AB would be area would be equal to IB by this delta B. Sorry, not rho, delta. Delta. This term is delta B. Okay, so you IB you calculated 340. So IB value is 340. This you have assumed 7. So you get an area around 48.57. Let's approximate close to the next integer value, that is 49 millimeter square. Now one more important thing is here, D and L value are given, but it's an induction motor. I told you induction motor needs to be skewed such that there is no phenomena of crawling. Crawling means it does not operate at 1/7 of its speed. So the skewing phenomena is very important. So length of rotor bar, let's give some space for crawling, like 0.4 millimeter. So length of rotor bar is already mentioned. Here they have given length 0.125, and let's add plus 0.45 to it, because let's add zero point 0.4. This is the standard practice, so remember this for skimming, and for dia you have to subtract it with 0.15. This is a standard practice. 0.17 meter you will get. Now copper loss in rotor bars. There are two losses in the end ring and the rotor bars. So the rotor bars copper loss should be equal to the number of, how many number of rotor slots are there, that is 57, and your IB square RB. IB square RB into SR. Your RB is rho LB by AB. Rho LB by AB. So one thing is there, IB value you calculated 340, so 340 square. Rho value is given here in the problem. If you read the problem, it is given 0.02. So you can substitute this value here, 0.02. LB value you just now just calculated 0.17. AB value also you got around 49. So you can substitute this value 0.002. See here. Oh yeah, see here, 340 square into 0.02 into 0.1749 into 57. So you get a value of your copper loss in the rotor bars, and this happens to be around some value. You just calculate it. I have written it. So this copper loss would be equal to, yeah, total rotor copper. This is 457. It amounts around 457. You will get this value. Here I have just missed to write. So you just check how much is that value. So now the current in each end ring. Now end ring current formula yesterday only. Again I have told you, SR into IB, pi into P, where pi P is the number of poles. So number of poles is 6. SR 57. This calculated, pi calculated. So end ring current we received 1030. Area of each end ring, again that 7 we have assumed. AE is equal to 1030 divided by 7. So this comes around 147 millimeter square. Yeah, any doubts you are having? Yes, yes, please. So yeah, copper loss in the end ring would be, now copper loss, because two end rings you are having, so it is twice IE square RE. So twice IE square IE you have calculated. Okay. Now RE is again rho LE by AE. So this rho, this length of this thing is basically, in an end ring, is a circular cross section which will be given by your circumference. Your circumference is pi d. So this length rho value will remain, but this length we can replace by pi, your diameter, minus 15 mm. Why minus I'm doing 15? Because of that skimming phenomena. So there in the length I add 0.45, here I minus 0.15. Okay, so I get 3.14, into minus 0.15. So this I get as a length. See, this length is equal to pi d me. Okay, so instead of length I'll write this 0.96. AE I calculated. So AE I have calculated 1.147. Here I have calculated. IE also I have calculated. So I can write 2 into 1030 square into 0.02, So I get this loss as 264 watts. So the total loss is the loss in the bars plus loss in the end rings. So loss in the bars 457 plus loss in the endings 264. So this is 721 watts. So one important thing for this is rotor copper loss by rotor output is given by s 1 minus s. So this is no need for this. You can directly also calculate your slip. So if you do like this rotor, okay, rotor copper loss is 721 watts. Now divided by your rotor output, rated output. So here if you read the problem, your rated output is 15. Okay, so 15 kilowatts. So you can do like that also. So your 15 kilowatt. Okay, so you get the value of slip s 1 minus s, and you get the value of slip is equal to 0.458. Little tough because it's difficult to remember this formula and this and this. Directly also, if you want the value of slip, you can get. How you can get? Already in the problem, if you look at the problem here, he has mentioned your this rated speed is 950. Synchronous speed we calculated 1000. So we can calculate the value of slip. 1000 minus 950 divided by 1000. That means 50 divided by 1000 into 100. That is slip percentage. So it would come around 0.05%, or you can say 5%. Similarly, here also, if you are using this formula, also you will get close to it. See here, s 1 minus s. So you are getting around 0.0458. So 58 means close to. You can write this value close to 50 na. So this is very close value. So no need of doing this directly. Also you can do like this: 120 above 1000 rpm, and then substitute this value nr 1 minus s ns. So you are getting this value of 954, which is very close to 950 rpm. So my aim here was not to calculate this, but just to show you like how it can be done. The main thing we have to calculate is the effective rotor resistance. So for effective rotor resistance, we have already showed you the formula. This is the particular formula associated with it, where your effective rotor resistance is given as 4 ms ts square aw square rho ib ab sr plus 2 pi dme p square ae. So 4 is okay. MS will come for 3 phase 3. TS number of turns you calculated 216. You are substituting. This value usually is not given. This is the KW value. This is the space factor. This value you usually assume as 0.955 whole square. This value is given 0.02. IB value is IB value calculated here. I think by mistake I have written wrong value of IB. You have to substitute the value of IB what you calculated here. Here you have no, it's correct. No, sorry, not, this is not IB, this is LB 0.17. Okay, this is correct only. This is not IB, this is LB. LB value, LB, write down this LB. This is length. Your area of cross section AB 49. Your rotor slots 57 plus 2 pi. Your this dia 0.305. Your number of poles square. Your area of that entering area 147, and you will get the effective rotor resistance as 0.995 ohms. Now tomorrow we are having a class, okay, at 2 o'clock. So tomorrow you tell me, I want to conduct an exam. Like I'll be using a site called as wait one second, its name. Wait. I will just be sending you. Wait, it's called Kahoot. Okay, so you just install that Kahoot on your phones, and I will share you one thing. So I will prepare a multiple objective based questions, and each one of you have to answer that, and you will get a particular mark for that. That mark I will take as your that you will get only 5 to 20 seconds to answer the question. So that you have to prepare seriously, and those marks will be considered as
How
your
many questions,
internal
sir?
marks. Some you will see that not exactly your all the marks. This is one 10 questions I will prepare. It will be objective type questions, wherein small things we'll break down, and we'll see that how much you have understood. So till now,
Syllabus, sir.
whatever induction machine portion I have only induction motor. Whatever I have told you, taught you in induction motor. All my material is available in the Google Classroom, or if you are not comfortable going to Google Classroom, you can also see on YouTube. Okay, all the materials I have made a playlist. You can go there and you can see that also. And any other material if you want, like I can give you that also in the Google Classroom. It is there. Any other books and all if you want, like I will share with you, no problem. So you prepare well, because simply if you are listening, I am speaking, you are not giving me response, then how can we judge? See, our main function here is to make you learn engineering, not to pass an examination. Passing is not a big issue. You can mug certain things, go there, write, get out. So many engineers are coming out, electrical engineers, mechanical engineers, but the World Forum is saying that we are not having capable engineers. We require engineers, but the capability in the engineers is not there. So why is it so? Because we are not taking it very passionately. Like if you are studying induction motor, studying something we don't know what we are studying, we are simply mugging up. Some MB Rao, JB Gupta, like that books, Godse Bakshi will purchase. Some Sunstar, what is that? Sunstar, that last exam. I also have, but I purchased it just to see the question papers. Sunscreen, something like that is there, just to see the question papers, and there is a lot of mistakes in those books. Okay, simply someone will copy, you will not get the concept. Okay, examination is an important point of view. I am teaching you from the examination point of view only, but at the same time we should gain knowledge also. No doubt we have to get full marks, 100 out of 100 in EMD. Whatever we have to do, if we have to solve 10 years papers, whatever we have to do, we will do that. But only passing that examination, we should be able to get job also in the future. We should be able to face some competitive interview also. We should know. Now Fakresh asked a very nice question regarding this. Okay, you tell me about the frequency. Now I answered you this. Suppose tomorrow in interview somebody asks you this say very same question, and if you reply like I replied to you, you will be selected. But these type of things are not there in books. This type of things means you have to develop an insight for electrical engineering, join some electrical forums, okay, learn some programming language also. Programming language, these days, why all the computer IT work of electrical thing has been shifted to the IT sector. Basically this is our job. Electrical thing, planning, CPS, CAD, other softwares are there, or your MATLAB software. We are not really working on that. We are not developing the programming skills. Programming skill is very essential. If you are having core electrical knowledge, if you can design and program, then no one is better than you. If you can do what every Tom, Dick, and Harry is doing, then you will get the same salary. But if you are having core knowledge also, plus your programming skills are also there, then you can fetch any job in any big company. Okay, so we have to make sure that we have to keep that percentage also up there. Okay, if somehow over the years it's not there at that level, no problem, don't worry about that. Enhance some technical skills, make some entrepreneur projects, write some research papers, some review papers. So you have to think about moving forward in life, not looking digging back into the past. Stop thinking that we are slow learners, we cannot do it, and we need some special attention. No, everyone is great inside your class. I have seen you are replying, you're responsive. It is not like that. I felt like some people are very dumb over there. No, you are a very good bunch of people. But one problem with you is that you are not organized. Organized means if you are having a separate notebook for everything, you don't know what basically toppers are doing. They are just maintaining their, see what studies are. I will explain you what studies are. Study is like a differentiation. Examination is like an integration. See, study is how you have to differentiate. You have to take
Yes,
larger
sir.
chunks of portions like electrical machines. You have to differentiate into smaller parts. So every day you have to study little bit. Okay, for example, today I will do this derivation of entering, how it is coming. I will study, I will read. If I have any doubts, I will write those points. Tomorrow, sir is getting some salary. Why he is getting salary? He should not get salary for free. He should answer my questions. Okay, Tomorrow I'll make some homework for sir also. Let me ask him these questions. I'll
Yes, sir.
take it down there. Okay. Then I'll ask. Okay. But if see, at times we are also humans, we cannot answer your every each and every question because the knowledge is immense. So sometimes it may take time. Sometimes I can answer. Sometimes I can't. See, I'm not telling you that I am the godfather of electrical engineering or anyone is there or HOD or principal. So, but by thinking process, teaching and learning phenomena, teacher also learns and student also learns.
Shivram is there, sir.
Huh?
Yes, sir. Yes,
Shivram,
Shivam,
sir.
sir.
So, what Shivram is there?
Godfather, sir.
All-rounder, sir. He is.
Godfather of the
Okay,
electrical
godfather.
branch.
No, every every class we have like in my class also there was one guy called Vinod. So we used to call him James and we used to call him Ganesh Rao.
Yes,
That
Shivram,
time
sir.
we had Ganesh Rao was a teacher in MS Ramaya. He used to teach signals and system and control system, all the tough subjects he used to teach. So he used to take tuitions. Now also in Dollars Colony Sanjay Nagar he must be taking. So whenever this guy was called Ganesh Rao. So similarly you are calling Shiv Rama. So in every when I see to
Yes,
Shivam,
you
sir.
people,
Shivam.
Tuesday, sir.
okay, when I see
Tuesday.
to you people, uh,
Shivram
I
Pichai.
can relate. Okay, now you see when I see to you people, I can relate to my old days because I'm also a product of VTO. So I know how VTO exam works. Okay, that time there was used to be that brilliant jiggers. Now they have replaced with some sun star. One night before, if you study, you will be able to pass like that you are doing. But that is not worth because maybe sometimes you'll pass, but in VTO it is very difficult to pass. Okay, now it is they have made it very easy. When in our times it was very difficult. You know, people with me, I think 38 people went into engineering. Only 18 or 19 came out. Rest left the course. Okay. So now they are okay. The COPO mapping, this thing, that thing, they are doing. So it is very helpful. This is a golden era, but you have to still be on your footprints. You have to be still smart. And teachers significantly have improved. For you, they are giving almost all your teachers have done PhD degrees, so they have some insight onto subject. Earlier we were not having that much of caring was not there. Whenever teachers were not behind you like that. If you study, study. If you don't study, study. So this is a very golden era. You have to utilize. You have to utilize whatever information we have. So you please take care. So on this note, I want to take your attendance. So I see that 33 of you are there. So 33 of you have written in your chat section. 33. So I'll take the chat section attendance and wait. And wait. I will stop recording it. Okay. So then you can say whatever you want to say because otherwise the management it does not look good. But